Hi, so today we'll be talking about number 20 and number 21 from the Shinglee workbook on page 97. If you have that, you can go ahead and open it. If you don't, we're just going to be doing it here. So this is question number 20. A door 1 meter by 2 meter turns through 50 degrees from position ABCD to position ABEF, as shown in the figure. So what I want to note here is that CD would be 2 meters, so BA would also be 2 meters, and BE would be 1 meter because BC is 1 meter, and AD is 1 meter, so is AF. Okay, so for the first question here, it says find the length of DF. So how do we find DF? What I'm going to do is draw a line from D to F. So if you realize this, DF actually makes a triangle and it closes it up. That becomes DAF. So what I'll be using here is the cos rule. So the cos rule is essentially df square equals to 1 square plus 1 square minus 2 times 1 multiplied by cos of 50. So why 50? Because DAF is 50 degrees. So we will get 0.845 meters. That's your answer for DF. So for II, it says find the length of BD. So how do we find BD? We're going to draw a line from B all the way down to D. So it's going to be a diagonal line that becomes a right-angled triangle along with BCD. So what I'll be using is the Pythagorean theorem. So if we realize this, BD is actually the hypotenuse of this right-angled triangle. So what I'll be doing here is BD squared equals to 1 squared plus 2 squared, and then we're gonna end up with this, and we get 2.24. So that's our answer for BD. And then DBF. So DBF will actually end up looking like this. So this will be D, this will be B, and this will be F. So what was this? We're looking for this. So BD and BF are actually the same thing. So as we found before, it was 2.24. So 2.24, and FD from our I question is 0.845. So what we're going to be doing is this. Cos of DBF equals to 2.24 squared plus 2.24 squared minus 0.845 squared over 2 times 2.24 times 2.24. And you should get DBF should equal to 21.8. So this is question number 21. ABC are 3 points on a horizontal plane, and the point T is vertically above A. Given that BAC equals to 120 degrees, TB equals to 16 meters, and AC equals to 12 meters, and the angles of elevation of T from B and C are equal. So there we go. This would be equal. Find the height of AT. So what I want to note here is that CAT was actually 90 degrees because it's on a horizontal plane. So, okay, let's find the height of AT. So what I'm going to be doing here is I'm going to draw 2 triangles. So this is going to be B, this is going to be ATB, this is going to be AT, and this is C. So as you can see here, as we said before, the angles of elevation are equal. And this is right angled, this would be 16, and this would be 12. So we don't know what the angles of elevation are, so we're going to call them X. Okay, so we're going to be looking for it like this. Tan X equals to TA over 12, because tan is opposite over adjacent. And then sin X equals to TA over 16 because it's opposite over hypotenuse. So now that we found that, we know that TA is the same thing. So what we're going to do is this. 12 tan X equals to 16 sine X. So once you get that, you actually know from algebra that tan can actually change to sine over cos, so that, and becomes 16 sine x still. So what I'm going to do is eliminate the sine. So you end up with this, 12 equals to 16 cos x. So cos x equals to 12 over 16, and x will equal to 4.14. So keep in mind, this is only 4.14 degrees. It's only what x is. So we need to find AT. So eventually, AT, we're going to be using 16 sine x, because remember, this is the formula to how to find TA. So 16 sine x. So 16 sine times 4.14, and you get 10.6 meters. That's your answer for AT. So next thing is the angles of elevation, T from C. So we actually already found this. It was the 4.14, because remember, the angles of elevation are the same, and that was what it was. So that was 4.14. And we're going to be doing this here. The areas of ABC. So this is what it happens to be, ABC. So we know what AC is, so we need to find what AB is. So I'm going to be using the Pythagorean theorem here. So it would be AB squared equals to the hypotenuse, so 16 squared, minus the opposite, which we already found from here, so 10.6 squared. And there you will get 12. So now that we found that, we are going to find the area. So area equals to 12, which is AB, times AC, 12, times sine 120 over 2. And you should get 62.4 meters square. That was it. Thank you, and I hope you enjoyed it, and I hope the video was helpful.